Hello everybody, I Gnaneshwari V, Assistant Professor in Department of ECE, Maharaja Institute of Technology, Mysore. Welcome you all to today's session on electric wiring and lighting diagram, which is a part of Computer Aided Engineering Drawing VTU first year subject with subject code BCEDK203. In today's session, we will be discussing on Module 5, Multidisciplinary Applications and Practices. Coming to the agenda, in the syllabus, they have mentioned you need to study about automatic fire alarm system, call bell system, UPS system, basic power distribution system using any suitable software. So first one is automatic fire alarm system. What is a fire alarm system? It is a system that is designed to detect and alert the people during fire breakout or fire related emergency, right? So what are the components that would be required to identify there is a fire breakout? First, we need to have a processor, Arduino Uno R3. Then we are using a gas sensor, temperature sensor. Obviously, whenever there is a fire breakout, there will be a rise in the temperature and there will be smoke emission out of the gas, right? So we need to identify gas and temperature. Since they both are analog in nature, the input sensors are given to analog port or analog terminals of Arduino board. Okay, and what could be the output devices? If you have observed during the fire breakout, there will be a continuous buzzing sound and LED light glowing red alert saying there is emergency or fire breakout, right? So we are using a buzzer, that is a piezo, and then we are using LED. You can use any color LED you prefer, and we are using resistor in order to control the current flow direction of your output devices, that is your buzzer and LED. Okay, this is the circuit diagram that we have to build using some software, using all these components. Okay, so you have Arduino Uno board and then two sensors, that is an input sensor, basically a gas sensor and a temperature sensor. The gas sensor is connected to Arduino analog input A0 pin and temperature sensor is connected to pin number A1. So what are the output devices that we want? It is your LED and your buzzer. If you see, the LED is connected to your pin number 13, that is a digital output pin number 13, and buzzer is connected to pin number 7. Okay, and for all these things to work, we need to give a 5-volt supply with the ground connection. So using what software are we going to do this simulation is Tinkercad. Tinkercad is an online simulation software that is easily available. You just need to log in with your Gmail account and then you are good to go, and you can do a lot of simulations related to CAD. You can do 3D models, you can build blocks, and you can do animation, and you can also build the circuits, which is freely available, and you can try several experiments also out of it. Okay, so I hope everybody has seen this kind of device that will be placed in college or in hospitals, malls and big buildings, isn't it? So this is a fire alarm, fire detector. So whenever there is a fire breakout, this is going to detect, like basically how this part is going to work. So that will be inbuilt here, and then that will be given to your buzzer and your LED starts to glow. Okay, this is the kind of circuit that we have to build using Arduino in the simulation software Tinkercad. Okay, so I'm going to teach one Tinkercad circuit, how we are going to build it. The remaining one we will see how to go about it. Okay, so I'll just open here since I've already logged in. So if you observe, this is the screen you will be able to see. Using my Gmail account, I have just logged in here. And then if you just click on here, like you create, you can even do 3D designs of your CAD subject, and also you can do some code blocks. And then since it is a simulation, I need to do circuits. Okay, so I'll just click on circuits. So as soon as I click on circuits, I would be able to see a device, a page where I'll have a workspace and then list of components. Then I can have a schematic or circuit diagram, and then list of components I can observe here. And this is a place where I'm going to dump my codes to run it, and this is where I will be able to start the simulation. So if you observe in my workspace, there are already some components which is available here. But in order to use this components, like first what I'll see, I'm already able to see here there is Arduino Uno board. So I'll just click on it, and if you see, it is just coming onto my workspace. Okay, so I can increase. So Arduino Uno R3 name number 1. If you have two, if you have one more, then if I take another one, it will come here and it will show you second one. If I don't want, just click on that object and I will be able to see here the option as delete. So you want to delete it permanently, yes, you can just delete it if you want. Or in case if you want to retrieve it back, there is an Control Z button, you can even do it. Okay, now what are the different other components you are able to see in the circuit? So you have an LED, you have a buzzer, you have a temperature sensor, and then you have a gas sensor. So I will identify where are those okay, I can see there is a LED here readily available. So I'll click on that LED, I'll take LED, and then you can, if you observe LED color, I can change it to any required, green, yellow, white, anything. Since preferably a breakout will have a red LED which will be glowing, so you can use red. Or if you want any other kind of LED, since it's a simulation, you can use your preferable color. Okay, then I want a resistor. I want 2 resistor, because I'm going to control the current flow that is flowing through my output devices. So 1 resistor I'll place here. Another resistor I want for my buzzer. So I can't find the buzzer freely here, so I'll just type buzzer here. If you see buzzer, then I see piezo here, so I'll drag and drop on my workspace. And for this also I need to have a resistor. So I'll take another resistor and I'll keep it here, 1 kilo ohm itself. If you want, you can change the value here. Okay, you can have a different values are also available, so you can change as per your requirement. And then I want to have the breadboard, preferably a small breadboard. That's because it's a very small connection between your input terminal and the output terminal. Okay, and you can move your whole circuit. Okay, just with your mouse you can move it, and then you can also make it small by with the help of your, you can make it big, you can move, or you can make it small, or you can make it big with the help of your mouse. Okay, and then what are the other things I want? I need to have a gas sensor. So I will just type here gas sensor. So I got a gas sensor here. And then I need to have a temperature sensor. So I will type temperature. So I got a temperature sensor too. So if you see, there is already another temperature sensor that is available. So somewhere it is there. So I'll just take another one. Okay, and just anyhow we'll see later, it is going to pop out that there is an extra component without connection, so we will see that later. Okay, Now how to go about with the connections? If you see, observe it, there is a 5 volt supply here that I'm going to give it to my breadboard connection. You can do the wiring using your mouse, okay, and you can move around the wire to make it look straight, and you can also change the color of the wire. I want the live wire to be red, so I'll keep it in red. And the ground, if you see there are 2 grounds, you can just use any one of the ground and then take it and connect it, okay. Double tap it, you will be able to see. And then how I'm going to change the color here, I want the neutral, the ground one to be in black, so I will change the color to black, okay. And usually we make a lot of connections from, even on the other side I want a connection. So what we do is we'll connect the positive to positive, and I want positives to be in red. I'll change the color, and negative to be in negative. Negative to negative. Yeah, now I want to change the color to negative to black, so I'll take over here. And then I want to connect my temperature sensor and my buzzer, so I'm going to connect it. If you observe on the temperature sensor, there is a power cord. So power means, if you see power, V out, and then there is a ground. So power is always given to positive. So give positive, and immediately you change the color there and then, okay. And then you have a ground. Just go ground and give it to ground. Double tap it, and black color. And you are supposed to give your V out as I discussed in the circuit diagram. If you observe, the temperature sensor is given to pin number, analog input pin number A1, and gas sensor is given to pin number A0, right? So this will do the same thing, okay. So this one we will give it to A1. It is showing A1, okay. Now I'll just change the color to red because it's output. And then if you see for the piezo, I'll get the piezo a little nearby, and then if you see positive and negative, they have given. The positive is given to which pin number? The positive is given to the piezo is given to D13, right? So I'll see where is D13 available. Is piezo given to D13? Let me cross check. Piezo, it is given to D7, not D13. So I'll take it here. So D7 is somewhere here, right? D7. So I make a connection here. Since it's output, I'll keep it in red itself, okay? Another one is negative. So this one you can just adjust it as per your, since LED is crossing. Let me see where I can put, okay. And you can shrink it, okay, no problem. Then you have to connect it to your gas sensor. So gas sensor, your B1 port is given to positive, and your H2 is also given to positive. Like basically we have to give supply B1 B2 to supply, and then one end of the piezo, that is your A2, is given through your resistor, and then it is grounded. Okay, and then the middle one, H1, is also grounded. Since it's all ground connection, I want to make it look black. Okay, make it black. And this one, I need to give it to which circuit I had told. I have to give it to my A0 connection. Like I can just directly give it, but it looks little untidy, right? So I can just move my breadboard. Okay, fine, it is given to A0 now. And if you see, I have to connect my LED. LED has two port, cathode and anode. The cathode is given to ground. So if you see, there is a ground pin here available. So I'll directly give it to ground. And the other anode, I'll go to through my resistor. Okay, and then I'll come back to my 13th pin. And it is anode, so I'll prefer to keep it in red. Okay. So you can make it connect like this. Yes, now my circuit is ready, so I can run my circuit. Okay, so how I'm going to run my circuit is, I just need to go here for my code, and then here it is given the option blocks, but I am going to write the code using my text C++ codes. So it will ask you like, are you sure? Just continue and just delete all the codes that is available. Okay, and you type the codes which you want to run. Okay, I have readily available codes. Yes, so delete the previous codes and then paste it here. So you would be okay, just edit the previous thing. Okay, once you clear the previous text, like what was the thing, if you just go to code, then it will ask you like, what do you want? You want a text or previously whatever the codes that were written, just erase that codes and write your own C++ codes. And I've already written the codes for this. So I'll copy the same codes here. Okay, and then once your codes are ready, then if you want to see like whether what you have given, if you observe here for the temperature, I have given 80 degree. Preferably it's whenever there is a fire breakout or temperature, 59 degree is what the minimum will be given. You can change the value here, like you can even make it 70 or whichever the preferable value you want. You can just make it as per your requirements, and then you can start simulating. Okay, so it takes some time. Okay, anyhow, I have already available. So I've already written the codes and it is error free. So I'm going to do start simulation. So once I'm going to start the simulation, if you see already the buzzer starts to buzz. Okay, so why is it buzzing? Let me check. So okay, gas sensor is having some sort of smoke. So if I move away the smoke, let's see, oh, there is no buzzer buzzing, right? So similarly, see, if you observe, the smoke is moved away, If I get the smoke back, you can see visually the buzzer starts to create the sound. You can hear it also, buzzer sound. And once I move the smoke out of it, then I won't be able to see anything, right? Buzzer doesn't buzz. So similarly, if I want to check on my temperature, how much is the temperature and the gas sensor, if you see in the code what I have written, the gas sensor now it's normal, right? So but let me observe now when I get it back, the what would be the, so there is much gas now, right? Since it's a simulation based on the formula, it is showing you some defined value. Okay, similarly, so let's check with the LED output. Now buzzer stop, right? So if you see again the code, it's back to normal, right? But the temperature is still the room ambient temperature. Whenever there is a fire breakout, there will be a rise in the temperature. So what I'm going to do, I am going to increase the temperature rise. So how I'm going to increase the temperature rise here is, if I just click on my sensor, temperature sensor, I'm going to increase my temperature. So as I when increase the temperature, I hope it is visible here, the LED started to glow. Before in my codes, the temperature was, if I check back, it is 24, that's a room temperature. Now it is showing 101, which is more than the threshold which I had given 70 degree, right? So if I get back the temperature, let me see what is going to happen. LED turned off. So I'll check what is the temperature now. It is showing -4 degrees Celsius, right? So this is the simulation of the codes. I will be sharing it in the down description. You all can do simulation, and once the simulation started to run, if you want to stop the simulation, you can just click on stop, and then you're good to execute the next program. I hope the concept of fire alarm system that we had rigged up just now using Tinkercad was helpful for you to understand the fire alarm detection system. Okay, I hope it gave you some knowledge about how a gas sensor and how a temperature sensor are used to identify and give out the output devices a signal. Okay, now the next concept is call bell system. In call bell system, as you know, what is calling bell or call bell? It is a kind of signal that is given to alert somebody, right? So it could be in college, or it could be used in hospital, or it is also used in home, indicating that someone has to be attended, right? So that is a call bell system. So how we are going to design it here is using a Arduino board, and as you know, the call bell system usually be a push button switch, right? Push button. So we need a push button and bell, that is and again a buzzer itself, and then I want a resistor to control the current flow, right? So what is the circuit diagram? This is a circuit diagram in which in the circuit diagram the buzzer is given to the port number D7 since it's a digital, and a switch since it's a on and off. Usually a bell switch will be always normally open. Whenever someone wants to be addressed, that button is pressed, it is going to become normally closed, right? So the switch here, when someone wants to be attended, it get closed, normally closed. Usually it will be in normally open position. Okay, so you need to have or it is like a digital signal itself, 1 or 0, either it can be high or it can be low, right? So this is also given to your pin number
D2. Okay, so using Arduino board in Thinkercad software, it is a very simple connection. If you see, there is a buzzer and there is a push button and there is a current flowing. You are controlling through a resistor 10 kilo ohm that is given to pin number 3. Is it given to pin number 3? No, pin number 2, that is a digital output of pin number 2, and pin number 7. Okay, the same thing I have already rigged up the circuit, so I am going to show you the simulation of that doorbell system. Okay, so if you observe here, I will just I'll just go to simulate. Okay, I've already written the codes for this, where whenever the push button goes high, that is 1, that is the normally open to normally closed condition when it gets, then so I've already rigged up the circuit, so I'll just go to simulate and show you all the codes. Even this code will be shared to you all, so you all can work and get the output. So if you see, I have a push button here. So if you see the list of components, I've taken from here only push button, and this is your schematic diagram. Okay, where you have a push button and then you have a buzzer, and this is your layout diagram. Okay, so this is your calling bell, and that needs to be addressed with the help of your push button switch. Okay, so your switch is connected to pin number 2 and your buzzer is connected to pin number 7. Similarly, one end is given to ground, another end is given to positive, that is a plus 5 volt, and ground is taken from the Arduino. The Arduino will have an inbuilt power supply as designed by the Thinkercad here for plus 5 volt. Okay, so once you start simulating, if you see here, there are the codes that I have written here. The codes indicate that the 7th pin is output and the 2nd pin is input, and whenever the switch state is high, you have to give the output high. Whenever the switch state is less or low, that is, you have to make the buzzer low. That is all. It's only 2 conditions. Whenever the switch is high, you make buzzer high. When switch is low, you make buzzer low. That's the condition. Okay, so I'll just do start simulation. So I would be able to see here start. It's already started. Since it's a bell switch are usually a push button switches. As long as you hold, I'm holding the push button, so you are able to see calling bell buzzing. Once I release it, then the calling bell stops. Okay, so using the same steps that I built for fire alarm system, you have to go to Thinkercad and then create, and you will be doing a circuit, and then you will selecting Arduino Uno, breadboard, resistor, then push button switch and piezo, that is a buzzer, and make the connections as shown here and dump the codes in the code section, and you can simulate it. Okay, so again I'll demonstrate it. Once you press the push button, release the push button, then your buzzer stops. Okay, once you are obtained with the output whatever is required, you can just stop the simulation. Okay, fine. So this completes 2 sections. One is a fire alarm system and doorbell system or a calling bell system. Okay, so what is the third one that we need to discuss is UPS. I hope you all have seen in your colleges, with your system there will be one backup, right?
or there will be a room that is where you observe that there's a set of batteries where even when there is a power outage, you will be still continuously working with your system even during the power outage, right? So UPS is an uninterruptible power supply where it is going to give continuous power supply to your load, the loads which are critical in nature. For example, you can't give your UPS system to geyser, washing machine, because they are not considered as a critical loads, but whereas in the college campus or in industry or in hospitals, when some very important things are happening, then it could be in operation theater, or it could be in MRI scanning, or it could be with the industry where a lot of computers are there and people are working on it, then the places require uninterruptible power supply. So these are very critical loads, not the loads which you can do after some time also, like refrigerator, washing machine. These loads and all cannot be considered as a critical load. So UPS are used preferably for critical loads in order to provide continuous power supply during power outage. Okay. Using what are the things that we do UPS? Like we have a rectifier with charger, then battery bank, inverter, filter, and critical load, right? In your house or in college or anywhere, you would have observed that there will be a big tank batteries like this, which will be piled up in series connection, right? In a row it will be arranged, because in series connection the voltage get added, so you can get large amount of voltage, right? And also series parallel combination, they prefer it, so you can increase the current rating as well as the voltage rating. So the UPS ratings are always given in kVA rating, that is kilovolt ampere rating. So based on what type of load you are going to connect it, the critical loads, you will have a different ratings for your UPS. And battery is a DC supply where it is going to store a DC supply source in it, right? So a rectifier, we need it to be converted. Like what is it basically going to do? We know that we get AC supply to our house or college or hospitals, right? So AC supply cannot be used directly to charge your battery, right? Because battery is DC and AC directly I can't charge to use DC, right? So I need a mediator device where I can just convert from AC to DC. That is your rectifier. So rectifier is a circuit that converts your AC component into DC. Okay, and you need to have a battery bank. So you can have a series parallel combination in order to increase the voltage and current, right? And what is an inverter? For example, your house, you have TV that is designed to run for AC supply. And can you give directly your battery bank, which is DC, to your TV? That is not possible, right? So what we are going to do here is we need a reverse process which was taken place by charging the battery. Like what did happen? We converted from AC to DC, right? So in rectifier, what had happened? You had a supply, AC supply, and that got converted to your DC supply. And this DC supply, I used it to charge my battery, right? But I can't give directly this battery to my TV or my laptop. I can't give directly that, even though my laptop or my computer
take a minimum amount of current, but I can't give directly to that, right? So what I need to do, I need to do the reverse process of whatever we have done during the rectification process to charge my battery. What did I do? I converted AC to, what did I convert? I made it to DC, right? I made AC to DC. But now what I can do, I have to use it. For that, I need to convert it from my basic thing which is available, DC, I need to convert it to my AC supply in order to use it, right? So that is why I need to have inverter. Usually when we are doing a conversion from DC to AC, there will be lot of ripples or distortion or harmonics present. So in order to remove those things, we will be using filter. And why are we doing all these steps? We are doing all these steps for our load, that is our critical load. Okay, right. So if you observe the line diagram of UPS, you have your load here. This is your load L. And what basically happens, like for example, in your house you have a UPS system. You would have observed whenever there is a power out, if you see, automatically the power will be given to your load. At the same time, if you observe, your battery also is getting charged, isn't it? So if you see, this is your supply, okay, this is your supply and this is your load. Whenever there is a continuous power flowing, then the power starts to flow in this direction. So the power will be flowing from this end to this end, and then it will be going to your load. And at the same time, the power will also be helping your battery to get charged. Okay, why? Because only when the battery is charged and when this line fails, then your battery will take over the connection, isn't it? So if you observe here in this connection, the green line is eliminated because there is a power outage. So this line is not working, power cut is there. Then what happens? The battery will have what kind of supply I told? It is going to have DC supply. So that DC supply is given to which device? Component, that is an inverter, which is going to give you output AC. That is actually required for my load to run properly, right? So these are the basic components that is required. So what are the basic components of UPS? You have a rectifier with charger, battery bank, inverter, filter and load, right? So what are the types of UPS do we have? We have basically two types of UPS. One is offline UPS and other one is online UPS. So you would have observed in your college, even when there is a power cut, like for example as shown in this diagram, there is a very important component that is present here, right? That is called as a static switch. Okay, so static switch happens or occurs or switch over from one terminal to another terminal in microseconds. So whenever there is a power cut, your UPS will take over that is being provided to your desktop immediately within fractions of second, and you won't even identify that there was a power outage, isn't it? So how is that possible? If you observe in the motherboard, there will be capacitors present, isn't it? The capacitor, whenever there is if you see the charging and discharging of the capacitor, then the charging usually happens quickly, the charging, and discharging very slowly it will occur, the discharging of the capacitor. Okay, and this time with respect to time, if you see, okay, the charging discharging of the capacitor, the charging will be quicker and discharging will be very slow. Okay, so by the time that discharging, the capacitor, whatever the energy was stored, it will be giving for that minute whatever the microseconds of time, whatever is lagging, that it will be given by the capacitor. So by the time the capacitor completely discharged, it will be taken over by the UPS using the static switch. So the static switch will what do? Basically, whenever there is a continuous power supply from your transformer in your line connection, it will just directly take from here and give it to your load. Whenever there is a power supply, it will go like this using the static switch. Whenever there is a breakdown, or when there is a power outage or power cut is there, then it should go in this particular path. It will be there, obviously your battery will be charging, and in this circuit, as I have already explained you, it will go here, and then using this static switch, then the current starts to flow here in this direction, and these things will happen in fractions of seconds, like microseconds. Okay, so only these are offline UPS. So offline UPS are used in schools, colleges, and where a continuous power supply is not a critical factor of the electronic component. In those places, they will use offline UPS. Okay. Then the other type of very important thing is online UPS. So before going to what is, it's the same components. If you see the components of online UPS are, you have again a rectifier which converts your AC signal to DC signal. Then you're going to charge your battery, and then you will have an inverter which converts from a DC signal. You have DC here, and then the output of that, it is going to be AC, and that is given to your AC appliances, right? So where are they going to use this online UPSs? If you observe in hospital operation theater, a operation that is performed by a doctor is very critical, right? If power goes off, and an operation is an emergency situation, right? So you can't expect power fluctuation or power breakdown during that situation. So in operation theater or in MRI scanning room, or it could be in a LAN connection where along with the server that is connected, and you need to have a continuous power supply in order to not even to miss out a single to miss out any kind of drawbacks, or this is one of the drawback that is actually present in offline UPS, like that small fluctuation is not a big matter, the fluctuation of voltage. But in online UPS, even when there is a small fluctuation in the voltage, that all will be regulated, and a continuous power supply will be given through the UPS itself. Okay, so you are going to have usually you are going to get any appliances, like whatever that is connected here, the connected to AC appliances. These connections will be like operation theater. It could be a lighting system, or it could be a heartbeat measuring system, or it could be some scanning devices, or it could be monitoring devices. Any kind of devices that is connected, they all will be running through your UPS itself anytime. So it is not like there will be a AC power supply, then whenever there is a outrage, then you're going to have a battery that is going to convert it and then give it to the load. It is not that situation. It is basically going to convert your before giving to the load itself, it will be always given through your UPS. Okay, yes, so that completes your UPS section. Yes, power system. Electrical power system is broadly classified into three sections. One is generation, another one is transmission, and the third one is distribution. So the power system is broadly classified into generation, transmission and distribution. I hope you all have observed generating stations such as hydropower plant, nuclear power plant, thermal power plant, tidal power plant, tidal power plant, isn't it? So these are the generating stations. If you observe, these generating stations are far away from the localites or domestic consumers, isn't it? So how is this we are able to get the generated power to a consumer? There are different types of consumers. You can have a commercial consumer, you can have an industrial consumer, or you can have the major portion of the consumer is domestic consumer. If you observe from generating station to these type of consumer, I can't directly give power supply. So in order to give a best power supply to the consumers, we use transmission system. So if you observe, usually the generating station, first they will step up the voltage, and then I hope you all would have observed these kind of structures surrounding lanes or ring roads, right? What are these lanes? These structures are, these are called as towers. You have a different types of towers, okay? And then very important component of your transmission is your transformers. I hope you have seen transformers everywhere near your house, college, or near to the substations, isn't it? So these towers are used to transfer the power over a long distance, and that is being given to a transformer. And how it is going to reach us, if you observe near your house, lane, your city, your area, you have these kind of structures, right? These are called as poles. Yes, the poles are used to transfer the power from generating station to your consumers through the transmission cable. The process of transmitting from power from generating station to the consumer through the transmission cable is called as distribution system. Okay, usually the distribution, this is the single line diagram of a power system. If you see, this is a generating station which produces 11 kV and which is used a step up transformer for 11 kV bar 220, which is a primary transmission. Then if you observe, usually the reason why we do, there is, if you observe, there is step up, and if you observe anywhere below the line, you see only step down, isn't it? Because whenever we step up the voltage, many experiments have found that there is a lack or a low voltage drop is available. Okay, so in order to avoid voltage drops, there is increase in voltage level for the transmission. Okay, so 11 kV is step up to 220 kV, and then from 220 kV, you would have seen, right, near to the substation, they would have put some danger symbol with the skull and then indicating that danger, and below to that they will mention like 66 kV bar 11 kV or 11 kV bar 415 volt, like that you would have observed, right? That's the same thing here. As and when it reaches the down line here, as and when it comes down, you observe that the voltage is getting stepped down, right? Only from generating station to its next transmission process, we increase the voltage in order to reduce the power loss, and then as and when the transmission approaches to the distribution or the domestic consumer, the voltage is reduced. And every segment we are going to use, this is a single line diagram that is used to represent the transformer. Okay, so the transformer, the same circuit you can use or you can build it using your Tinkercad 3D model. Okay, you can build the single line diagram in 3D model. You can try this as a homework. You can build this model using Tinkercad 3D model, and then you can just observe it, like what are the different sections of a power system. Like you have a generation, transmission and distribution, right? Yes. So this in your syllabus they have told to focus on the distribution system. So what is the distribution system? Basically the distribution system happens or occur after your secondary transmission from here. Okay, so after secondary transmission, then you have a primary distribution, then you have a secondary distribution. Okay, primary distribution and secondary distribution are the two types of transmission under the distribution system. What is the primary distribution? Primary distribution is whenever there is a 11 kV or 33 kV coming from the transformer that is directly needed to some kind of commercial industry, commercial consumer, or for an industrial consumer is required, where they want to run like for example in the hospital, if they want to run the hospital with the 11 kV supply, then the hospital need to be given 11 kV, and they themselves will have a step down transformer which will be reduced to 415 volts, and then that will be taken over. Okay, so high voltage consumers are coming under the primary distribution system, and low voltage consumers like us, like what we require in small scale industry or in hospitals or in school buildings, we require 440 volts per 230 volts. This is what the supply we receive it, isn't it? At home we receive 230 volts itself, we don't receive 440 volts. So 440 we don't receive it because it is a three-phase system, right? Three-phase, and 230 volts is a single phase system. To your house you are going to get single phase or three phase? We receive single phase power supply to our house, right? So it is a 230 volts power supply. What we get? 230 volts. 50 hertz is the frequency of this whole power transmission from here to here. Whatever the transmission occurred, it occurred throughout is 50 hertz. From generation to distribution, it is 50 hertz of frequency range. Okay, even the components that is designed, like it could be a transformer, it's the main component that is happening or helping us to transmit the power from, along with the high tension cables and the poles. Apart from that, the transformer playing a major role in conversion, right? Voltage level conversions. Apart from that, if you observe here in the transformer, there is two things. One is your input and other one is your output. But if you see, there is a two lines present here, isn't it? These two lines indicates that there is an electrical isolation between your primary, that is your input circuit, to your output circuit, right? So whenever there is some fault occur in your input terminal, your output terminal, whatever is connected here, will not get affected by it. It will get isolated because electrical connectivity is not there. For example, think there is a lightning happening because of thunder and it's raining, and there is some problem in this part of the line. Okay, then this portion is under the fault now. But this portion, if it is directly connected, if there was a direct line connectivity from your primary distribution to your domestic consumer, then because of the fault or because of the lightning, the whole load that is connected to the domestic would have been got damaged, isn't it? Then there would be a lot of loss occurring. So in order to avoid that situation, the transformer is preferably given with an electrical isolation. So what these two lines indicating? It gives us an electrical isolation between two circuits. One is an input and another one is an output circuit. Okay. So what are the types of distribution system do we have? We have a primary distribution system and you have a secondary distribution system. A primary distribution system is basically given to industry or commercial purpose, and secondary distribution is given to the consumers. So you can build this single line diagram in Tinkercad as a 3D model and you can just observe it. Okay. Yes. So as I explained, it is basically with the high voltage and secondary distribution where you have a 400 or 440 volts and 230 volts, that is a single phase supply. So yes, coming to the summary, what are the things that we discussed today? We discussed about fire alarm system, call bell system. Using Tinkercad we simulated. I will be sharing the codes using C++ in the description, so you all can work on those models and you can simulate by yourself. And then we also studied about UPS and what are the different types of UPS. What are the different types of UPS are available? Online, majorly we use online UPS and offline UPS. And then we studied about distribution system. So you can work on 3D model of distribution single line diagram using Tinkercad. Okay, this is about the summary of today's session. If you have any doubt, you can drop message in the comment section. We will clarify it. Thank you.